In today's video, we'll be looking at the properties of logarithm. And if you have not subscribed to this channel, kindly subscribe. When a new video is being uploaded, you'll be the first person to be notified. Let's get started. Now the first one is what we see as such. Now in property 1, it says that the logarithm of any number to the base of the same number is 1. Now we can think of logarithm of e to the base e, then we are going to get 1. If you have logarithm of 2 to the base 2, we are going to get 1. Or better, if we have logarithm of 10 to the base 10, then we are going to get 1. Provided the argument and then the base are the same number, then we are going to get 1. So that is property 1 of the laws of the properties of logarithm. We are dealing with properties of logarithm. Now we continue to the second property. Now the second property says that the logarithm of 1 to any base is 0. The logarithm of 1 to any base is 0. Now we can have logarithm of 1 to the base e. The logarithm of 1 to any base, once we have the argument to be 1 and then it's to any base, then we are going to get 0. So if you have logarithm of 1 to the base 2, then definitely we are going to get 0. Provided the argument is 1 and then it has any base, we are going to get 0. If you have logarithm of 1 to the base 10, then definitely we are going to get 0. So that is property 2. Now in all the properties we are talking about, the base e should not be equal to 1. And then the base e should also be greater than 0. So it complies with the first one. The base e should not be equal to 1, and then we are looking for positive values for the base, which means logarithm does not entertain negative numbers. So let's bear that in mind. Now we continue and we go to the next property. The next property is what we call the reciprocal logarithm. The reciprocal logarithm, which means the logarithm has been reciprocated. Now we can think of logarithm of x to the base e. Now if you want to reciprocate this, it means 1 must be divided by this logarithm, which means we're going to have 1 out of logarithm of. Now once we are dividing the logarithm by 1, or 1 is dividing this logarithm, then we are going to interchange the positions of the argument and the base, which means x is going to assume the position of e and a is going to assume the position of x. So in this instance, we have e base x, e base x. Now we can think of example like logarithm of 10 to the base 2. Now if you want to apply the reciprocal logarithm, then it's going to be 1 out of, now we have the logarithm here, which means this argument and base are going to change their positions, which means we're going to have logarithm of 2 to the base 10. Now we can also have an example like logarithm of 8 to the base 3. Now the reciprocal logarithm can be applied such that we have 1 out of logarithm to the base now 8 and then the argument 3. So this is the third property of logarithm, and we continue to the next one. That's the last one, and it says that the logarithm exponentiation. That's property 4, logarithm exponentiation, which means the logarithm now is serving as an exponent. Now we have a to the exponent logarithm of the argument b to the base e. Now this is what we are saying. If something like this happens, now let's identify the similarities. We can see that there is a here, and then the a is serving as a base. So once a is serving as a base to the logarithm, and then when it comes to the logarithm side, a is also serving as the base, then it means the a and a will go, and then what will be left will be the b. So in this instance, our answer now is b. Now we can take example for more understanding. Now if you have 6 to the exponent logarithm of the argument 4 and then the base 6. Now once we see that this base has a logarithm, 7 as the exponent, and then when it comes to logarithm part, 6 is also 7 as the base. Now we can see that they are the same bases, so they will go out, and what will be left is the 4. So our answer now is 4. So it means the common numbers will go and whatever is left will be our answer. Now we can also think of an example like 2 logarithm of 3 to the base 2. So just like you just guessed, the answer is going to be 3 because we have 2 here, you have 2 here, and our answer is now 3. Now let's try whether you'll be able to identify this as the correct answer. So you have 16 exponent logarithm of 4 to the base 16. So what do you think could be the answer? I'm giving you 3 minutes. You've already said the answer. So which means the answer now here is 4. So that is the logarithm exponentiation. Now having known the properties of logarithm, let's try these examples. So exercise on the properties of logarithm. It says using the logarithmic properties, simplifying the following. So we are going to apply the properties we've learned earlier. Now it says logarithm of 1 to the base 3. So like we said earlier, logarithm of 1 to any base is 0, which means our logarithm of 1 to the base 3 is equal to 0. We do not care about the base it has, provided it's logarithm of 1 to the base, we are going to get 0. And that's how we can solve this. Now we continue, and in the second example we have logarithm of 500 to the base 500. You remember with the first property we said that logarithm of a number to the same number is going to give us 1, which means our logarithm of 500 to the base 500 is going to be 1, and that is it. Now the next example we have here as logarithm of the argument 4 exponent 2x plus 1 to the base 4. Remember that we said that logarithm of a number to the same base is 1, which means our logarithm of 4 base 4 is going to give us 1. That is it. Now let's look at the exponent. From the laws of logarithm, we said that if this happens, then this 2x plus 1, 7 as the exponent, is going to serve as the coefficient to the logarithm. We are referring this from the laws of logarithm, which means we can have our solution as 2x plus 1 logarithm of 4 to the base 4. But we know that logarithm of 4 to the base 4 is giving us 1. So in this instance, then we have 2x plus 1 multiplied by 1. And at the end, we are going to get the same answer, and that is 2x plus 1. And this becomes the solution to this question. Now we go to the next examples. The next one, we have log e exponent, the logarithm of s squared to the base e. Remember? Yes, so with this, once there is e here, and then there is e7 as the bases, the bases are all e, then our answer is going to be s squared. So we have s squared left, and s squared becomes the answer. That is absolutely fine, which means e logarithm of e x squared is going to be x squared. Very simple. Now we continue, and the last one we have 10 exponent logarithm of 7 to the base 10. And once we can see there is the same basis here, then 10 logarithm of 7 to the base 10 is going to give us an answer of 7, and that is absolutely right. And so this ends today's video. Well, thanks for watching. Kindly like, comment, subscribe, and share. This is BakoMaths. We are thinking beyond infinity. See you in our next video.